All right, so this session we'll talk about the strategy pattern. This is one of my favorite design patterns. It's also one of these patterns that every developer should know and have in their arsenal of tools. The Wikipedia defines the strategy pattern as being a behavioral software design pattern that enables selecting an algorithm at runtime. So our implementation of this will show a number of key capabilities with the strategy pattern, and we'll wrap it up by showing how to to select algorithms at runtime. All right, so we're going to implement the strategy pattern using Visual Studio Code and Spring or Spring Boot microservices. And our use case will center around a payment processor type of operation. Along the way, we'll write some code and we'll implement this payment processor application in a way that is typical of how developers will just write code to get the work done. But then we'll begin to refactor that code, and ultimately we'll land on the strategy pattern. So let's get started. And what we're going to start with is a Spring Boot application. We'll create a Maven project, use 2.67 Java. We'll just make this an arbitrary ID, and then we'll call this strategy design. And it will be a jar file. We'll use 11. We'll pick a couple of extensions. Spring Boot DevTools will give us an ability to make changes to the code, save it, and restart the server. And then Spring Web for giving us API capabilities. We'll put this in the, let's see, I have a development folder somewhere here. Here we go. And the project gets created. We have a Spring Boot dashboard, so this will allow us to run the project and open up the browser, and then we'll use the Java projects view to begin adding additional classes for our use case. So if I start the server and go to the browser, you'll see the typical error page. We have our base Spring Boot application up and running. We're going to use, again, a REST API to implement this payment processing use case. So we'll start by creating our first class here, and we'll just call that Payment API. And I need to add some annotation here to allow Spring to understand that this is a REST API. So we'll add the REST controller, and then we want to add an endpoint here. So we'll add another annotation called get mapping and provide an endpoint. And our first method will simply return a string called payment, a method called payment, and we'll simply return payment processing API. Save that. We'll see that the server restarts. And if we go back to our browser and add payment, okay, this is what we are expecting to see. So, all right, so we have our payment API. Now, this is, like I said, a payment processor application. And what we're going to do is we're going to demonstrate the strategy pattern using 3 methods. So the first method is display. The second method will be something like validate. And then we'll have a third method, print receipt. And so throughout the development of this use case, we're going to rely on these three methods, and obviously these are just some sort of example methods, but does serve the starting point for developing the an application, that has a requirement around payment processing. So this is our base, and then we'll start with this. All right. So the first thing that we want to do here is we want to refactor this and put this logic around payment processing into its own class. So let's start with that. Let's create a class called payment processor. And what we'll do here is we'll add those three methods that we talked about before. So we'll add a method called display, and it's simply going to return a string. We'll add a method called validate. And then we'll finally add a method called print receipt. And then we'll go back to our API class and use that class. I better save it. And so we'll create an instance of this payment processor. And then we'll use that payment processor to display the information from the methods that it offers. So payment processor.display. And then we'll copy this a couple more times. And I'll fix the, oops. Okay, so this one would be validate, and then this guy will be print receipt. All right, so we save that, go back to our browser, refresh, and so we have our class now producing the strings regarding payment display, payment validation, and printing receipt, although that should be a T. Okay. All right, so let's say now we have a requirement coming in that says we want to process multiple types, right? So we have types like maybe credit cards and let's say PayPal. So to fulfill that request, we're going to come back to the API. We're going to add a request parameter so that we expect that the API will pass in the type. We'll make this a string, and we just call the request param type. And then we'll use that in the payment processor. So we want to pass a type in here, and because we don't have a constructor that accepts a string, we're going to have Visual Studio Code help us out here. So we'll add that constructor to the payment processor. Then in the payment processor, we're going to add a field here called payment type, and assign that field to the incoming payment type. So it'll be this dot payment type is equal to type. Now with this, we should now be able to have the API pass in a type. So let's go back to our browser. If I run this API now, this is going to fail because it's expecting that type that we passed in or that we set up. So now I'm going to add the request param called type and associate it with credit, and our information that we expect to show up shows up. If I do PayPal, the same information will show up here. Okay, so this is kind of expected, but now we want the API and the processing to be specific to the type. So I could just simply go in here and say displaying credit when type is equal to credit. So for that, and this is typical, right? So you have some requirements coming up, and you want to make code changes to fulfill those requirements and get these changes in front of the stakeholders. So you might be inclined to just come in here and begin to use that type in this fashion. So we might say something like if this dot payment type dot compare to credit, then we're going to print the string here. And pretty straightforward, right? This is typically what you might end up doing to get something working. And then the same thing we might want to do for PayPal as well, right? So we might want to say something like, if our type is equal to PayPal, then print PayPal information. Otherwise, just simply return the payment type is unknown. And now if I go into the browser, run this for credit, now this will tell me that, yes, I'm indeed dealing with the credit payment type versus PayPal. I'm dealing with PayPal. So, again, this is typically what you start doing to get your work done and then to begin to, demo and add these features as these requirements come in. So the problem here, though, is that as you do it this way, you begin to introduce ultimately a maintenance nightmare, right? So, you're basically violating the single responsibility principle by supporting multiple types and allowing this one class to manage the display, to manage the validation, and to manage the printing. Okay, so what we're going to do here now is we're going to begin to consider a different approach, at least for managing these types